Hello.
Oh yeah, it gives me the option to leave the meeting.
There we go. Don't leave, don't leave. So today I am just working with a student, and I thought I would make a little video for the answer key of the factoring quiz. And just so everyone knows, I will be putting a new version of the factoring quiz out there probably in the next couple days, just so that it's available for students to retake. So I'm really encouraging you to retake it and get the best score that you can get. I'll always use your highest score, so don't worry. And I'll be calling it a new factoring quiz. So what I'll do is when I go to do your grades at the end of the semester, I'll include the best factoring score that you have. And then I'm going to do one on solving equations that's due next week. And then I'll do the best one of those that you have. So all of these topics, I'll keep on putting kind of new ones out there for you to try so that you can improve your score in all of these topics. So the first problem on the factoring quiz was x squared minus 5x minus 6. And now when I'm looking for the greatest common factor, I'm looking to see if any of the terms have an x or x's or whatever variables, but they don't. And I'm looking to see if there are factors on the x, which is the one coefficient that is a common factor of 5 or 6. And since 5 is a prime number, it doesn't have any factors. And so there's nothing in common between 1, 5, and 6. So my greatest common factor is just a 1. Okay, then we're going to ask ourselves how many terms we have. So terms are variables or numbers that are being added or subtracted. So this is a term, this is a term, and this is a term. So there are 3 terms. So when we use the factoring flow chart that I gave you, and hopefully everybody had a chance to print that out. If not, give me your address. I am happy to put one in the mail to you. So because it's 3 terms, when I said show me your options, your only options are going to be a parenthesis and a parenthesis. And the only way we can make an x squared is an x times an x, because we're visualizing where we did the FOIL multiplication, and that would have been in like lesson 1.5, I believe, 1.4 or 1.5. So we're trying to visualize putting this back together, if that makes sense. And I'll show you how we'll put it back together to check our work in a moment. So because I have 3 terms, this is my only option. And I am looking for numbers that multiply to make this here. So when we have 3 terms, we say that the coefficient on the x squared is an a. We call the coefficient on the b, on the x term a b, and then we call the constant a c. So we're looking for numbers that multiply to make a times c, which in this case, because a is a 1, it makes it simple. So we're really just looking for factors that make a -6. But uniquely, they have to add to make a -5. So I'm just writing they have to add to make the b, which in this case is a -5. So the factors that do that make a -6 have to be opposite signs, a 1 and a negative and a positive. So we've got 1 and -6, -1 and a +6, 2 and a -3, and a -2 and 3. And Mary Jean, if you don't mind, if you give me a thumbs up if you're good.
Sorry.
No, it's okay. If you have questions, just interrupt me. This is for you too. Mainly for you, because we set up this time. So the reason I'm looking at the factors first, so if we visualize this where we're going to multiply these back together, right, to get, to get our FOIL, we're going to have these combinations. And the thing is, the last 2 pieces right here and right here, they always multiply to make this last number, the c, which is a -6. And the reason we're listing those first is because there is a limited number of numbers in the world, 2 numbers that were multiplied to make a -6. This is it. That's the only list. And the reason we don't start with numbers that add to make a number of a -5 is because in my imagination, I could say, well, a -10 plus 5 makes a -5, right? I mean, I could come up with a bazillion two numbers that add to make a -5, but we're going with this limited list here. And then I'm going to add them all and see which one makes the number that I want. And so this is, it's going to be this pair here, 1 and a -6, because it uniquely multiplies to make the -6, and it uniquely adds to make the -5. And so that means I can just plop them in here. So this is going to be an x minus, oh, sorry, x plus 1 and an x minus 6. And you could have flipped the 1 and the 6. They still had to be +1 and -6, but you could have put them in the opposite spots. That would have been okay. I'm going to just do this to show that that's my work. That's my answer. If you can note that on your, when you turn in your work. But I'm going to check it just for a minute. I want you all to see why it works. So if we were to multiply these, we would get x squared. And then distributing this x here, we would get a -6x. And then that means I have to distribute the 1 as well. So 1 times x is a +1x. And then a 1 times a -6 is a -6. And then notice that they multiply to make that -6. And then they uniquely always will have these two binomials will always have, or usually have, two middle terms that are common like terms that we can combine. So this is x squared, and this becomes a -5x minus 6. So I'm going to give it a check because we got back to our original. Are we good on that one so far? Okay, so let's look at number 2.
So for possibilities there, that would just be the 1.
Yep, that's the only possibility that we can have. If you have that factoring flow chart that I went through, that's our only possibility. Is going to be 2 binomials. This is called.
Okay.
2 binomials. And the more you use that factoring flow chart, hopefully the stronger your skills will be at making the choices of this is where I need to be. Okay. So number 2 was x squared minus 5x plus 6. So it looks very similar to what we had, right? They're numbers they have to add to make a -5 in the middle, but they have to multiply to make a +6. So I kind of did that on purpose so you can maybe use some of your list again in some way. So similarly, our greatest common factor is a 1. And similarly, we had 3 terms. Because there's 1, and there's 1. Okay, and so this time we need to find numbers that multiply to make a +6, but we want them to sum or add to make a -5. So 2 numbers to multiply to make any positive either have to be both positive, right? Or they could be both negative. And so this time we have a -2, -3, and a +2, +3. So they're the similar pairs, it's just their signs are a little bit different this time because they have to multiply to make a +6. Are you good on those pairs so far? Okay, that's okay. Please interrupt me because there's probably somebody at home that's not sure. If there's something you're not sure on, somebody at home is probably not sure too. So now I'm going to add them just like I did up top. This time they're going to add to be a little bit different numbers. 1 and 6 is 7, a -7, a -5, and a +5. So here's my unique pair that multiply to make a +6 and add to make a -5. And again, my only options were this set of binomials. Because the only way I can make x squared is an x times an x. So again, I'm always visualizing that multiplication happening. So far, so good?
Yep.
So I'm going to plot my -2 in there and my -3. And then I'm going to put it in a box just so Mrs. May knows exactly what my answer is. And then I'm going to just check my work for a minute. So I like to do my arrows where I'm distributing. So my x times x makes the x squared. I have a minus 3x. And then I have a minus 2x and a plus 6. And that's where I get the minus 5x. So x squared minus 5x plus 6. Let me get a check. Any questions so far? Okay. So the next one, so question number 3 was 49x squared. Nope.
No, 9x.
81. It was 81x squared, right?
9x squared minus 49.
Okay. 9x squared minus 49.
Yep.
Okay, so again, I'm looking for, first thing I'm doing is looking for a greatest common factor. I only have x's in this term, so there's no x's common. And 9 only has factors of 3 and 3 and 9. And then you can always check with a calculator. If it's like, I'm not really good with my factoring, you could check and say, okay, does 49 divide by 9 evenly? Nope. What about does 49 divide by the 3 evenly? Nope. So they don't share any factors in common, so it's 1. Okay. And then I'm counting how many terms I have. So I have 1, 2 terms. And then my only options, so on my factoring flow chart, sweetie girl, my kitty's here to visit me.
Mhm.
Let's go through the factoring flow chart. So my factoring flow chart, so I don't have to write them all out. When I have 2 terms, I have 3 options.
Oh.
So I have to ask myself the question of how many terms. So if I had 2, you're really asking yourself a question. What are the exponents? So mine are both, my x is a squared, right? So I really only have one option then, which would be a difference of squares. So if I had cubes, it could be this difference of cubes, which is 2 terms, or a sum of cubes, which is 2 terms. But mine can only possibly be this one if it is in fact that one.
I don't have that page.
I put it out on our 84 in our Canvas.
Okay. I probably printed it and put it in my other thing and just
Okay,
didn't.
in your 104 pack maybe or something.
Yeah. I'll have to double check it.
So
Otherwise I'll reprint it.
if I can make a difference of squares, then I have to have something squared minus something squared. So, and that means 9 would have to be a perfect square of something. So you can check this in a couple different ways. You can say, you can take and say, oops, no, not that button. You can say, is 9 a perfect square root? And it is 3. That's one way. Or you could just start going 1 squared, 2 squared, 3 squared, 4 squared. Whoopsie daisy. That should have been 3. Oh gosh. I'm going to clear all this out. Okay, 3 squared, 4 squared. So that's one thing is you could kind of go through and do that. So we can see that this is 3x squared. That is a something squared minus, and then I'm going to do the same thing. I'm going to say, I'm going to find the square root and see if 49 is a perfect square root, and it is 7. So this is something squared minus something squared. So it fits our mold. Okay, so I'm going to just write the rule over here. It's a squared minus b squared. if it fits this mold, which it does, then my factors are exactly this. A minus B times A plus B. So ours factors into exactly 3x minus 7 and 3x plus 7. And I'm going to go like this and show I'm done. And I want to reassure everyone, this whole factoring bit doesn't, it depends on your 104 instructor. They might put a little 1 factoring or 2 factoring on your 104 exam for maybe your first test, but it really doesn't come into play until like chapter 4 or 5. So that's a good thing. You've already noticed probably by working on chapter 2 that there isn't a lot of factoring besides 2.1. The rest is all equations with x to the 1, right? Everything's been solving x to the 1 equations, which has been nice. Okay. So question number 4 was factor this. Okay. So again, my greatest common factor is a 1 because there's not x's in both, and 8 and 1 don't share any factors. So it's a 1. And then I ask myself how many terms, and it's 2. And so I'm looking for my, because here are my 2 terms. I'm looking for my possibilities. Well, the last time it was 2 terms and it was a difference, but this is a plus. So, and take note that my exponent is a 3, not a squared. So I know it's not the first one that we did in the last problem, right? So I'm going to look down below. I have a difference of 2 cubes, but ours is a plus, and there it is, a sum of 2 cubes. If I can make it into something cubed plus something cubed, I can use this format. So you can either use a cube root on your calculator, or you can go through and say 1 cubed, what is it? 2 cubed, what is it? Oh, it's 8. So I can make 8 into something cubed. It's 2 cubed. Okay. So this is 2x cubed plus, I love 1 because 1 can be to the anything. So it's 1 cubed. So I have something cubed plus something cubed, right? Just like we wanted. So I'm just going to write our little pattern out here. I'm going to write it over here. So a cubed plus b cubed will factor exactly into a plus b times a squared minus a times b plus b squared.
Only took you 45 minutes.
Hey, if somebody have any of those brown gloves and then that closet, I think they're on the floor. Maybe clean up a little bit up there.
So ours is a something, it's a something cubed plus a something cubed. So we're going to rewrite it in this format. It can factor into 2x plus 1. And then 2x, I'm just going to put it 2x squared. We'll work that out in a minute, because that's the a squared, minus the 2x times 1 plus the 1, oops, plus the 1 squared.
Yeah, you in there by yourself?
Yeah, I'm on the computer. Can you wait a second? Sheesh.
So 2x plus 1, 2x squared is 4x squared minus 2x plus 1.
On the floor.
You're good. I muted you, so you're all good. You're all good. I just want to make sure you got this down, so I'll wait for you to get that. You can always unmute yourself. Okay. And then the last problem, problem number 5 from the factoring quiz was ax plus 2x plus 3a plus 6. I always look for the greatest common factor, but this ax doesn't have any numbers, on it as a coefficient besides a 1. So these are not going to have any common factors 1, 2, 3, and 6. And then there's only x's in the first 2 terms, and there's not an a in the last 2 terms. So 1 is my greatest common factor again. And then my terms are 4. So I have a term, a term, a term, and a term. And so there's only one option. If it is factorable, it has to be the factor by grouping. So I'm going to group 2. I usually pick the first 2 and look for what's in common, and then the second 2. So I'll show you how that's done again. So I'm looking for the greatest common factor just between these first 2 terms, which is just an x. And I'm going to write that out in front, and I'm going to make a parenthesis. And if I factor out that x, I have an a left over. Plus, if I factor out the x from the 2x, I have a 2 left over. And then I'm going to kind of put that in parentheses. So that makes the first 2 terms. If I were to multiply this x back through, it would be a times x plus 2 times x. Plus, I'm going to look to see what's in common between the last 2 terms, 3a plus 6. And it looks like they have a 3 in common. So I'm going to factor out the 3 out in front, just like I did the other one. And I'm going to parenthesis. So I'm kind of like making it look like a distributive problem, right? I would distribute these if I wanted to go in the other directions. That's how I'm always visualizing. I'm undoing that. So if I factor out a 3 from 3a, I have an a left. Plus, if I factor out a 3 from 6, I have a 2 left. You can also think of it as 3 divided by 3 as a 1a and 6 divided by 3 as a 2. That's another way. Now, once I am done with that, I have to look at the big picture. Also, just a note, notice that a plus 2 was left over here and a plus 2 was left over here. If you're doing the grouping by factoring or factor by grouping, whatever is left over here will always be left over here. And if not, then it can't be factored. And because they have the same thing left over here, a plus 2 is really my thing that's in common. So I can say a plus 2 is a thing. And now what's really left over is x plus 3. And remember to kind of give yourself a break and go, you know what, these 2 really make sense. That one I'm still struggling with. All these topics we're going to be working on all semester to keep building our skills.